Hi everyone, welcome to mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is a pure mathematics 3 for October-November 2020, and the code is 9709/31. Just for your information, the content of this question paper is same as 9709/33, okay, which is a variant 3 paper. So let's move on to question number 1. Question number 1. Solve the inequality 2 minus 5x is greater than 2 times modulus of x minus 3. Okay, so since we are given one function, one straight line or one linear function, and another one is a modulus function. So the easiest way to solve this inequality is by using graph. Okay, therefore, I'm going to sketch two graphs on the same diagram right now. So now the first graph is going to be 2 minus 5x, and then the second graph is 2 bracket x minus 3. So instead of the modulus function, I sketch just the normal function first. Alright, so for y equals to 2 minus 5x when x equals to 0, because we know that the degree of x is 1. So we just need 2 points to get a straight line. Alright, so when my x equals to 0, my y is going to be 2. And then when my y equals to 0, I will get 0 equals to 5x. Sorry, 2 minus 5x. Therefore, 5x equals to 2, hence the x equals to 2 over 5. So this is when y equals to 0. Okay, so here are the 2 points. Now, same goes to y equals to 2 times x minus 3. So when x equals to 0, my y is 2 times minus 3, which is minus 6. And when my y equals to 0, I'm getting 0 equals to 2 times x minus 3. Therefore, my x minus 3 equals to 0. Hence, my x equals to 3. So these are the another 2 points. Okay, so now I will mark these 4 points on the same diagram. Okay, so let's say this is my axis. These are my axis. So this is y. Now from here, we know that your y is minus 6 when x goes to 0 for the second graph. Okay, therefore from here, but you should understand that the original is the modulus function. Now I'm counting without the modulus, which means after I have taken the modulus, this value is going to be positive 6. Okay, so means that I have to mark my y value, my y-axis, at least up to positive 6. So here will be 5, 4, 3, 2, 1, and 0. So I'm not going to mark the minus 6, okay, because later I will just do the reflection. Otherwise, the graph will be, taking a lot of space. Okay, then this will be 0. Now, for the x values, when you look at the calculations here, my x will be 0, 2 over 5, 3. Okay, so here probably, here is 1, this is 2, here is 3. So to get the accurate graph, you are advised to use the same scales for x and y axis, which means if here is 1 centimeter, then here should be 1 centimeter as well. Okay, so now without wasting any time, then we will just mark the points. So the first point will be 0, 2. Okay, so 0, 2, this is the first point. And then the second point is that x equals to 2 over 5 and y equals to 0. So 2 over 5 is roughly here. This is our 2 over 5. Okay, so now we join 2 points using a straight line, using a ruler. Make sure it is a straight line. Right, even though my straight line is not accurate, so you just draw a straight line using ruler. Okay, drawing that 2 points. So I will label this as my first function, which is 2 minus 5x. Now for my second graph, it will be, Okay, when x equals to 0, y is minus 6. But as I mentioned just now, your original function is a modulus. After we have taken the modulus, this is 6. So this is 6, but actually the original one should be here. Okay, so then the other point is at x equals to 3, y equals to 0. That means it's over here. So remember, the original line should be like this. Is this a straight line? Alright, so make sure you draw a straight line. The line is not very straight. Okay, then now, because of this negative part, okay, we are sketching modulus, therefore we are flipping the graph, reflecting the dotted line on the x-axis. That's why I will mark it at positive 6. So when you reflect it, it's something like this. So then we have to extend the graph. Okay, so you will notice that both graphs are intersecting. So probably like this. Okay, so just try your best to sketch a graph. Make sure it's a straight line. Okay, so now then I will label this graph as y equals to 2 modulus x minus 3. Now for your information, okay, for you to solve this inequality whereby the straight line is greater than the modulus graph, so obviously it will be this part. Okay, because the orange line is greater than the green line. Then I have to find what is the intersection point. What is this intersection point? Okay, but then you should understand that this negative part, this is the reflected graph because our original graph is the dotted line. Okay, what we need to do here is the equation of this reflected graph is negative of 2 brackets x minus 3 because initially the intersection is at minus 6. Okay, so how to get positive 6 from minus 6 means that you times another minus outside. Alright, so when you are dealing with this kind of question, then you have to be careful. So for my working, I'm going to erase this dotted line. Okay, because I'm not showing the y-axis up to negative value. So now I need to find the intersection points, which is our question mark. So it will be done by solving y equals to 2 minus 5x and y equals to negative 2 times x minus 3. So I have to solve these two simultaneous equations. Okay, so for the intersection point, two minus 5x equals to negative 2 of x minus 3. Then from here, I will do expansion. The right side will be negative 2x plus 6. Then left hand side 2 minus 5x. And now to get the x, right, this minus 5x will be moved to right side and the plus 6 will be moved to left hand side. Then from here, you will be getting 2 minus 6 equals to minus 2x plus 5x, which means minus 4 equals to 3x. Hence, I will be getting x equals to negative 4 over 3, which means this question mark is negative 4 over 3. Okay, so now from here, I know that in order to get the straight line, which is our orange line, is greater than the green line. That means our region should be less than the intersection points because the orange line is greater than the green line for the value of x which is less than negative 4 over 3. Okay, so from here, I will just write 2 minus 5x greater than 2 of modulus x minus 3. The solution is going to be x less than negative 4 over 3. Okay, so this is the method of, or this is the solution of this question number 1. Okay, I'm using graph method to solve this question. Alright, so for question number 2, on a sketch of an argand diagram, shade the region whose points represent complex numbers z satisfying the inequality modulus z greater equals to 2 and modulus z minus 1 plus I is less equals to 1. So from here, we know that modulus z greater equals to 2, that means this is the circle equation. Alright, so I will write in this general form first, so that this is a circle with center 0, 0. It is at the origin because of the 0 plus 0i. And then the 2 is representing the radius. Right, so for the other one, modulus z minus 1 plus I less equals to 1. So again, from here, I will change to general form, which is by factorizing negative from second and third term inside the modular sign. That means you will be getting 1 minus I. Okay, then from here, this is another circle with center 1, negative 1 because of the minus I there. So minus I is same as minus 1i. Then again, the radius is going to be 1. Okay, so now we have to draw 2 circles on the same argand diagram. So now I will label, let's say this is the imaginary and this is the real axis. Now, center 0, 0, radius is 2. So that means, let's say here 1, 2, 1, 2. Okay, this is a 0. Now, center 0, 0 means that it will be here. This is the center. And then since the radius is 2 units, that means upper part is 2 units, to the right is 2, bottom is 2, and to the left is minus 2. So now we just need to join all these points to get a circle. Okay, let's say this is a circle. Now another circle is at center 1, negative 1. So negative 1, 1, negative 1 is over here. And then the radius is 1 unit. That means 1 unit to the left, it will be at minus 1. Then 1 unit on top, it will be on the x-axis 1 unit. Then on the right is 1. And then bottom is 1. So this is our second circle. So when draw, please draw a smooth circle. Okay, so when I do labeling, this is modulus z equals to 2. That is the circumference. And for the red color, it will be modulus z minus 1 plus I equals to 1. Okay, so when you look at the diagram, the inequality now, the distance here, right, from the center is at least 2. So at least 2 means that when it is 2, then it will be on the green color. So at least 2 means that it will be more than that. So it means that it is over here. Okay, and then at the same time, this is less equals to 1. The distance from the center to the circle is to the region is less equals to 1. So when exactly 1 is on the red color on the circumference. So if less than that, that means it's inside the circle. So which means the region that's satisfied by both inequalities will be the shaded region. So probably I will just shade it using blue color. So that's the shaded region of the that satisfied by both inequalities. Okay, so now let's move on to question number 3. The parametric equations of the curve are x equals to 3 minus cos 2 theta, y equals to 2 theta plus sine 2 theta, whereby the theta is defined from 0 to half pi. Show that dy dx is cotangent theta. So to get this dy dx, we need to apply the chain rule, okay, which means from the x, since this is in terms of theta, then you have to get dx over d theta first. So when you differentiate 3, it will be 0 because there's no theta. Differentiate negative cos 2 theta. We know that when you differentiate cos fx, it will be negative sine fx. Then differentiate fx, it will be f prime x. So which means you'll be getting negative f prime x sine fx. Okay, so from here, I keep the minus. Differentiate cos minus sine. Rewrite the 2 theta. Now differentiate 2 theta, it will be a 2. Therefore, this is going to be 2 sine 2 theta. Okay, and same goes to y equals to 2 theta plus sine 2 theta. So our dy over d theta. So differentiate 2 theta is 2. Differentiate sine. Okay, so now when you differentiate sine fx with respect to x, so I will get cos fx, and then differentiate fx, it will be f prime x. So for this case, when you differentiate sine 2 theta, it will be a plus first. So differentiate sine is cos, remain the 2 theta, differentiate 2 theta is a 2. Okay, so these are the two differentiations, but now we need to get dy over dx. This is same as dy over d theta times d theta over dx. Probably you can just write dy over d theta divided by dx over d theta. Okay, so it is the same because d theta over dx is same as 1 over dx. 1 over dx over d theta. Right, so from here, I will get 2 plus 2 cos 2 theta over 2 sine 2 theta. Then from here, we can factorize the 2. Then you'll be getting 1 plus cos 2 theta over 2 sine 2 theta. And now the 2 can be cancelled off from both numerator and denominators. Now, by looking at the answer, you need to get just one term, which is a cotangent theta. Okay, so now we know that cotangent theta is cos theta over sine theta, which means I cannot remain 2 theta over here. So I have to change to identity. So cos 2a is 2 cos square a minus 1. Okay, of course we have another form, but here we will just choose this because this is 1 plus cos 2 theta. So this minus 1 move to the left hand side, you will get 1 plus cos 2a. It will be 2 cos squared a. So then when you compare, your a is basically theta because here cos 2a and this is cos 2 theta. Okay, and same goes to sine 2 theta. So for sine 2 theta, we have the double angle formula. Sine 2a is 2 sine a cos a. That means obviously now your a is theta. Okay, so now by applying these two formulas or these two identities, we will be getting 2 cos squared theta, okay, divided by 2 sine theta cos theta from the green color formula. Then from here, the 2 will be cancelled off. Okay, cos squared theta divided by sine theta cos theta. So the squared from the numerator, so I can just cancel 1 degree and with the denominator. That means you will be getting cos theta over sine theta. So therefore, this is cot theta. Okay, so this is the solution for dy dx. Okay, next question number 4. Solve the equation log 2x plus 1 with base 10 equals to 2 log x plus 1 with base 10 minus 1. So since here we have both terms with log base 10, so I will change the minus 1 to log base 10 as well. That means log 10 2x plus 1, okay, equals to 2 log base 10 x plus 1 minus the 1 I will change to log 10 10 because we have a formula 1 equals to log a. Right, so from here, since now you have 2 log on right side, though now I have to combine first, but before we combine we have a formula, okay, so which is log a power b equals to b log a, and then I'm going to apply log a plus log b, sorry, it is minus, equals to log a over b. Okay, so first of all I will apply log a to the power of b formula, because if you need to use the second formula here, make sure both coefficients are 1. Okay, both coefficients are 1. So now these two must move up. Okay, therefore my working becomes log 10 2x plus 1 equals to log with base 10 x plus 1 squared minus log with base 10 10. Then now only I will combine using the second formula over here. Okay, therefore this is log with base 10. Since this is minus, means this is division, so it will be x plus 1 squared over 10. Now since you have 1 log on both sides, which means my next step is just to ignore the log from both sides, then I will be getting 2x plus 1 equals to x plus 1 squared divided by 10. Okay, so now to solve this and give your answers correct to 3 decimal places. So look at the hints here. Answers means you will be getting more than 1 x value. So then now what to do is this 10 will be moved up to the left side. Okay, then I will be getting 10 brackets 2x plus 1 that equals to x plus 1 squared. Then now I will do expansion. So left hand side will be 20x plus 10. Right hand side will be x squared plus 2x plus 1. I'm expanding this using a plus b squared equals to a squared plus 2ab plus b squared. Okay, to get these 3 terms. Now, since we have the x squared on the right side, so I will move all the terms from the left to the right side so that it will be a quadratic equation later on. So I will be getting x squared plus 2x plus 1 minus 20x minus 10 equals to 0. So when you simplify this, it will be x squared. It will be x squared, 2x minus 20x, so minus 18x. Then 1 minus 10 is minus 9 equals to 0. So this is the quadratic equation. Okay, so now you can try to factorize this, but unfortunately you can't factorize it. That's why the question is asking for 3 decimal places over here. So what we do is we need to use the quadratic formula. So for your information, if let's say ax squared plus bx plus c equals to 0, this is a quadratic equation. The formula is x equals to minus b plus minus square root of b squared minus 4ac over 2a. Okay, then now when I list down the values of all the coefficients, so my a is 1 because 1x squared, b is negative 18, c is minus 9, then my x is going to be minus b. So minus 18 plus minus square root of b squared, so minus 18 squared, minus 4, a is 1, c is minus 9. Then over 2a, a is 1. Then from here, when you simplify, you will be getting 18 plus minus square root of 363, then divided by 2. Okay, so when you count this correct to two values, right, the first one is counted by using negative, then you get negative 0.487, and the next one is going to be 18.526. Okay, so now we get two values, but then are they the final answers? Right, you can check. So from here we know that for the log, okay, you have to do checking because initially it was not a quadratic. You simplify into quadratic. So now you have to check. Make sure 2x plus 1 is greater than 0 because log cannot be negative. And then x plus 1 must be greater than 0 as well. So now, if let's say 2x plus 1 is greater than 0, right? So 2x plus 1 is greater than 0. And also x plus 1 is greater than 0. Okay, from the question, right? That means my x should be greater than negative half and x is greater than negative 1. So obviously this negative 0.486 is greater than negative half because this is negative 0.5, and this 18.526 is definitely positive. All right, it's definitely greater than both of them. Okay, therefore I will just write my solution. X is these two values. So every time when you are solving the log problem using this kind of method, you change to quadratic equation, you must check, okay, are they satisfying the original equation? Otherwise, you cannot accept all the values. Okay, so with this, we have completed this question, number 4. Okay, so next question, A, 5A. By sketching a suitable pair of graphs, show that the equation cosec x equals to 1 plus exponential negative half x has exactly two roots in the interval x from 0 to pi. So when you want to show there are how many roots in the equation, that means it is same as how many intersection points. Okay, so now you have to show that there are exactly two intersection points. So before we sketch the cosec x, right, let's for your information. So cosec x is basically 1 over sine x. Okay, so now when I sketch sine x from 0 to pi, so this is my sine x. Now, when you need to sketch cosec, right, let's say I sketch now. So here's 0. Let's say this is pi, because here is pi over 2, right? So let's say here is pi over 2. Now, the original graph for the sine x. So when x goes to 0, when you convert to cosec, 1 over 0, it will be infinity. Okay, same goes to the pi. That means 1 over pi will be infinity, which means infinity means that it will be asymptote. The graph will be will not be touching this point, this line, this dotted line. It will be approximating, or it will be approaching. I would say it will be approaching this dotted line. Okay, at these 2 points, x equals to 0 and pi. Now, when it is pi over 2, this is 1. Okay, so it means that 1 over sine pi over 2, right? So the sine x itself, it will be 1. So I'll get 1 as well. So which means, okay, when at pi over 2, this is going to be 1. Okay, but then this is maximum. So 1 over maximum, it will be minimum, which means, okay, this is a minimum point. So therefore, I will just simply sketch and get this graph. Make sure it is a minimum point. Alright, so this is my cosec graph. That's why it shows here it tends to infinity. Okay, so it's not very, it should be symmetrical. Okay, let me draw again. Alright, so this is my y equals to cosecant x. Now another graph is you need to sketch 1 plus exponential negative half x. But before that, I'm sketching e half x first, or ex first. So just for information, right, ex is this. This is your ex. So if let's say e half x, here is 1. This is x. So when it is e half x, we know that the half x means, e negative x, I'm sketching e negative x, it will be 1 over ex, which means 1 over 1 still 1, 1 over 0, because this part tends to 0, it will be infinity, right? So, and then here is infinity, it will be 0. So this purple graph is my e negative x. So now we are sketching e negative half x. The shape will be the same. So you should understand that it will be approaching the x-axis, right? So now since you move up by 1 unit, this is plus 1, means you move up the graph by 1 unit, means that now instead of approaching the x-axis, it will be approaching 1. Okay, so which means now for my another graph, it will be approaching 1. Okay, so it means that instead of intersecting at 1 over here, so now it will be moved up. That means it will be intersecting at 2. So let's say here is 2. Okay, so my graph, another graph is going to be like this. So this is my y equals to 1 plus e negative half x. Okay, so then from here, you will get 2 intersection points. Right? So then you can just write there are 2 intersection points. Hence, there are 2 real roots. There are exactly 2 roots in the interval of 0 to pi. Okay, so that's the solution of this question. Okay, now part B. The sequence of values given by the iterative formula xn plus 1 equals to pi minus inverse sine 1 over exponential negative half xn plus 1 with initial value x1 equals 2 converges to one of these roots. Use the formula to determine this root correct to 2 decimal places. Give the answer of each iteration to 4 decimal places, which means now xn plus 1 is pi minus inverse sine. Just rewrite the whole formula. And now you are given x1 is 2. So just calculate x2 using x1. And then each steps, it will be 4 decimal places. So from here, I will be getting x2 equals to pi minus inverse sine 1 over e negative half times 1 plus 1. Then calculate this using radians mode. Okay, so this one, radians mode in your calculator. Then from here, you will be getting 2.3217. Alright, so now continue for x3. So now again replace the xn now by x2, which is 2.3217. Then after that you plus 1. Okay, mistake here. The plus 1 is the normal size. Then you will be getting 2.2760. Now, when do we stop this iteration? You check here, answer 2 decimal places. That means you must get 2 same decimal place. But now, it is not. That means you have to continue for next step. So now I'm getting x4. Then you will be getting 2.2824. And again, they are different. So we have to calculate one more step. So your x5. Then this is going to be 2.2815. Okay, so when you compare with the previous, by x4 you get 2.2824. By x5 you get 2.2815. So you are getting 2 same decimal place. Now check the next digit. So if the next digit is 5 and above, then you round up. Otherwise you can just get the final answer. So my roots will be approximate to 2.28 according to the calculation. Okay, so question number 6. Express square root 6 cos theta plus 3 sin theta in r cos theta minus alpha, where r is greater than 0 and alpha between 0 and 90 degrees. State the exact value of r and give the alpha equal to 2 decimal places. Okay, so now when you look at here, this is cos. Make sure in the expansion, first term is cos. Therefore, we can just follow the sequence here. Okay, so now your r is basically square root of the square root 6 and 3 squared. Okay, so you plus together, this is square root 15. And this is the exact value for the r. Now, your alpha value is inverse tangent 3 over square root 6. Then this is going to be 50.77 degrees. Therefore, square root 6 cos theta plus 3 sin theta equals to square root 15. Then cos theta minus 50.77 degrees. So that's the solution for 6A. Okay, now 6B, hence means use the previous answer. Solve the equation square root 6 cos 1 over 3x plus 3 sin 1 over 3x is 2.5, whereby the x is from 0 to 360 degrees. Okay, now let's compare with previous. Square root 6 cos 1 over 3x. Just now, we found square root 6 cos theta, which means your theta now becomes 1 over 3x. Okay, so now I will write this question I will direct use the formula, the form that we have found in previous step, but we change the theta to 1 over 3x. That means it will be square root 15 cos 1 over 3x minus 50.77 degrees. So here I will get square root 15 cos 1 over 3x minus 50.77 degrees. Okay, so you can write here from A, theta is 1 over 3x. Then now, cos 1 over 3x minus 50.77 degrees will be 2.5 divided by square root 15. Okay, and this is going to be 0.6455. So now, since the cos is positive value, okay, that means the angle will be in first and last quadrant. But of course, first of all, we have to get the new interval because you are given x from 0 to 360 degrees. But then now you are solving 1 over 3x minus 50.77 degrees. Okay, so now I will get the new interval first. My x is given 0 to 360 degrees. Alright, then now when I consider 1 over 3x, it will be from 0 to 120 degrees. Then after that, 1 over 3x minus 50.77 degrees. So you use 0 degrees minus 50.77 degrees, then you get negative 50.77 degrees. And the other one will be 69.23 degrees. Okay, so now the cos is positive, which means it will be in the first and last quadrant. So now I will get my basic angle. So 1 over 3x minus 50.77 degrees. When you take inverse cos of 0.6455, you will be getting 49.797 degrees. Here I give more decimal places because later you need to plus with 50.77 and times by 3. So same goes to this value. This is going to be 49.797 degrees. Okay, so now when you write down the final answer, look at this interval. You can accept negative value up to negative 50.77 and then positive value is 69.23. That means my first angle is positive and my second angle is negative based on the diagram. Okay, so therefore I will write here positive 49.797 degrees and negative 49.797 degrees. Then now I will move the negative 50.77 to right side. So when you plus with 50.77 degrees to the results on the right side, the first one becomes 100.567 degrees and then the next one is going to be 0.973 degrees. Okay, and at last you get to times the whole equations by 3. So I will get x equals to 301.701 degrees and the other one is 2.919 degrees. And now we always leave our answer correct to one decimal place for the angle in degrees. Therefore, final answer for the x will be 301.7 degrees and 2.9 degrees. So that's the solution of this question. Okay, now next question, number 7a. Verify that minus 1 plus square root 5i is a root of this equation. So to verify means that you show by replacing the values. So means that I will let fx be the cubic equation or cubic function. I will say cubic function. Okay, then since your equation here is x, so now means that this is the x. So now I will replace the x by minus 1 plus square root 5i and do expansion later on to show that the final answer is 0 because the right side is 0. Then here is going to be 2 bracket minus 1 plus square root 5i cube plus minus 1 plus square root 5i squared plus 6 times minus 1 plus square root 5i, then minus 18. Now, For the cube, okay, I will use the binomial expansion, or probably I will just use the Pascal triangle. If let's say you have a plus b degree 0, you will get 1, okay? Then a plus b degree 1, it will be a plus b. So the coefficients will be 1 and 1. Then a plus b squared, it will be 1, 2, 1. Because Pascal triangle says you just keep writing the 1 at the front and at the back. Then the middle value is addition of the previous coefficients. So now my a plus b cubed is going to be 1 at the front and at the back. So 1 plus 2 is 3. 2 plus 1 is another 3. So this will be my expansion. Or that will be my coefficients of the expansions. Means that I will be getting equals 2. So the first one is 1. But then the term is minus 1 cube. Okay, the first coefficient. Then plus 3, because here is 3. Then minus 1 squared, square root 5i. Plus 3 minus 1. So you must drop 1 degree from the first term and add 1 degree from the second term. Square root 5i squared. Lastly, here is 1. Okay, so plus 1 times square root 5i cube. So this will be my expansion for the cube. And then for the next one, which is quadratic expansion, I will be getting 1 minus 1 squared is 1. Then minus 2 square root 5i. Then plus square root 5i squared. Okay. And then the next one is just expansion. So here is going to be minus 6 plus 6 square root 5i. Then minus 18. Then from here, when we solve or when we simplify the terms inside the bracket, the first one minus 1 cube is minus 1. Okay, so second term, 3 times minus 1 squared, this is basically 3. So 3 root 5. Now, the next one is minus 3. Then square of square root 5 is 5. I squared. So my I squared is minus 1. Okay, or probably you can just write I squared first, no problem. So now I will just write this is minus 15 I squared. And then the next term is cube of minus 5, cube of square root 5i. Then you will be getting plus 5 square root 5i cube. Okay, so then the next one is going to be 1 minus 2 square root 5i. Then square of square root 5 is 5, then I squared. And then minus 6 and minus 18, these two can be simplified into minus 24. Then plus 6 square root 5i. Okay, so now I will simplify. I square is minus 1. That means this is minus 1. Here is minus 1. And then the I cube. I cube is basically I square times I. That means it's minus 1 times I. Then I will be getting minus I. So that means, right, this is minus I. Alright. Then now I will just simplify all the terms. 2 brackets minus 1 plus 3 square root 5i. Then minus minus is a plus 15. Then the next term is negative 5 root 5i. Plus 1 minus 2 square root 5i. Minus 1 times 5 minus 5. Then minus 24 plus 6 square root 5i. Then now you can simplify or you can just direct times. So 2 times minus 1 you get minus 2. 2 times 3 root 5i plus 6 root 5i. 2 times 15 it will be 30. Then 2 times negative 5 root 5i minus 10 root 5i. Okay, then now I will simplify 1 and minus 5. This will be minus 4. So I will write minus 4 minus 2 root 5i. Then minus 24 plus 6 root 5i. Okay, so when you calculate this, right, when you simplify this, minus 2 minus 4. So minus 24 is already minus 30. Together with this 30, you get 0. Okay, and same goes to the I. 6 root 5, 6 root 5, so is 12 root 5. Then this is minus 10 root 5 minus 2 root 5, means that it's another minus 12 root 5. So positive 12 root 5 minus 10 root 5, it will be minus 12 root 5, it will be 0. So from here, at last I get 0. Okay, so my f of the minus 1 plus square root 5i equals to 0, which means I have proven this equation. Or on other words, minus 1 plus square root 5i is a root of fx equals to 0. Okay, so that's the solution of this part. Okay, now B, find the other roots of this equation. So when you look at the equation, 2x cubed plus 1x squared plus 6x minus 18. So all the coefficients are real numbers, which means the conjugate of the complex number is another root. And at the same time, since the equation is with degree 3, this is a cubic equation, which means you should get 3x. Okay, so if you are given one complex root, the conjugate must be the next root. That means you will have another real root. Okay, so now I will just write given x1 is minus 1 plus square root 5i, then x2 will be conjugate is minus 1 minus square root 5i. Okay, so now I have found two roots, but we need another one root. Therefore, we have to get the factor first. Okay, write these two roots in a factor. So to get the factor is x minus the root itself. So minus 1 plus square root 5i multiply with x minus 1 minus square root 5i. So this is how we get the factors. So now you just do expansion. Right, x times x, then x times the bracket in the second bracket here, then do expansion. So then I will be getting x squared minus x times minus 1 plus square root 5i alright, and then minus x brackets minus 1 plus square root 5i. This is minus, because when I do expansion, I will times, okay, x times x, x times this. Therefore, I'm copying this. And then this bracket, because it's negative, so negative x, and this bracket, just rewrite. So at last, this minus and minus is a plus. So I will get plus minus 1 plus square root 5i multiplied with minus 1 minus square root 5i. Okay, so now when do expansion, x squared, now you expand again, it will be plus x plus square root 5i. Okay, then expand here, so you will get plus x minus square root 5i. Now for the last two expansions here, I will just use the formula a plus bi multiply with a minus bi. This is going to be a squared plus b squared, real part squared plus imaginary part squared. That means it will be minus 1 squared plus square root 5 squared. So that's the shortcut. Okay, so from here, I will be getting x squared. X plus x is 2x, and then the square root 5i will be cancelled off. So I will get plus 2x, and then lastly, minus 1 squared plus square root 5 squared, it will be just plus 6. These are my two factors. Right? So then, what we need to do the next is, I have to find another factor using polynomial division. So then now I will divide So then from here, refer back to the equation, 2x cubed plus x squared plus 6x minus 18. That will be my function. So now in order to get 2x cubed from x squared, I need to times by 2x. So I will write here, 2x times x squared, 2x cubed. 2x times 2x, it will be 4x squared. 2x times 6, it will be 12x. Then now you minus. First term will be 0. Second term is x squared minus 4x squared. It will be negative 3x squared. 6x minus 12x will be minus 6x. Then minus 18. And now to get minus 3x squared from positive x squared, you need to multiply with negative 3. So then do expansion for the rest of the terms, and you will be getting the same terms. Alright, therefore, from here, when fx equals to 0, that means you are getting x squared plus 2x plus 6, which is our divisor, multiplied with the quotient 2x minus 3, and equals to 0. Okay, so then for the first quadratic equation, we know that it will be x equals to minus 1 plus square root 5i, and then minus 1 minus square root 5i, and lastly, when you let 2x minus 3 be 0, it will be 3 over 2, which means the other roots will be minus 1 minus square root 5i, and also 3 over 2. So these are the other two roots for this cubic equation. Okay, next question, number 8. The coordinates xy of the general points of a curve satisfy the differential equation for x is greater than 0 is given that y equals to 0, is given that y equals to 1 when x equals to 1. Solve the differential equation, obtaining an expression for y in terms of x. So now, x dy over dx equals to 1 minus 2x squared multiplied with y. So for this question, to solve the differential equation, we need to split the variables, okay, or separate the variables. So since your dy is the numerator, that means the y should be moved to left side. So I will write 1 over y dy equals to 1 minus 2x squared. This x moved to right side becomes divided by x. Then the dx move up. At the same time, you must integrate both sides. Okay, so for the left hand side, you only have one term. We are going to use ln later on, but for the right side, numerator has two terms and denominator one term. Therefore, I will change to two terms, 1 over x minus 2x squared over x dx. And further simplify this to get integrate 1 over x minus 2x dx. Okay, now for the left hand side, to integrate 1 over y dy, we have a formula. Integrate f prime x over fx dx. It will be ln fx plus c. Okay, provided the degree of the fx must be 1. Right? So therefore, from here, where I differentiate the denominator for the left hand side, differentiate y is 1. Okay, therefore, the left hand side is directly ln y. For the right hand side first term, same as just now. Differentiate x degree 1 is 1. Therefore, 1 over x, when you integrate 1 over x, it will be ln x. Okay, then for the second term, integrate negative 2x, it will be negative 2x squared over 2, then plus c. Now, the 2 can be cancelled off. Then I will rewrite now. Ln y equals to ln x minus x squared plus c. And now, given that x equals to 1 and y equals to 1, so this is for us to find the c value. So which means ln y is 1 equals to ln x, x is 1, then minus 1 squared plus c. So ln 1 is 0. So here is 0. Therefore, Your 0 is minus 1 plus c, hence the c is 1. So now I will get ln y equals to ln x minus x squared plus 1. Okay, but when you refer to the question say get the y in terms of x. So it means that I have to eliminate the ln. Okay, so what we need to do here is probably you can just move the ln to left side. Okay, I group the ln first. So here is going to be ln y minus ln x equals to 1 minus x squared. And then use the formula that I have shown you just now. Ln a minus ln b is ln a over b. So I change to this form first. Ln y over x equals to 1 minus x squared. Okay, and then to eliminate the ln, we can just take e both sides. So e ln a equals to a. Therefore, when I take e ln both sides, left hand side will be y over x, then right hand side will be e 1 minus x squared. Okay, or probably I just show you step by step. So left hand side y over x, right hand side just rewrite. So at last I can get my y by just moving up the x. So I will get x e 1 minus x squared. This is the first method for you to simplify. Otherwise, okay, or you can use this method. Ln y equals to ln x plus 1 minus x squared. So I will just direct take e both sides. So I will be getting e ln y equals to e ln x plus 1 minus x squared. And then since you have the summation of the power in the e, then we have to refer to another formula, which is e a plus b. It will be e a times eb. So you may use this. Then I will just change this to e ln x times e 1 minus x squared. Okay, because e ln x, I can apply this formula. It will be just the x itself. And from the left hand side, e ln y, it will be y. Therefore, you are getting the same solution. Okay, so that's the solution for this question 8. Okay, question 9. Express fx in partial fractions. So first of all, you check the highest degree of x in the numerator is 2, but then the denominator here is 1, and this is 2. So when you do expansion, that will be degree 3, which means this is the proper rational function. Therefore, the polynomial division is not needed. Okay, we can just direct find the partial fractions. So now 8 plus 5x plus 12x squared over 1 minus x multiply with 2 plus 3x squared here. So now the first one is the 1 minus x, therefore just rewrite. And then the second one is square of 2 plus 3x. This is the repeated factor. So I will start with degree 1 for 2 plus 3x, then followed by degree 2 for 2 plus 3x. Then since all these are linear factors, therefore numerators will be constants ABC. Okay, then now you get the same denominator as in the left hand side. So now we need to do expansion, or we need to do comparison. I would say comparison. So now we have 1 minus x. Okay, that means you need to multiply with the square. So for the second term, b over 2 plus 3x. Now we have degree 1. Okay, here degree 1 means that we need degree 1 and this term. So I will times with 1 minus x multiply with 2 plus 3x. Okay, same for the last term, c over 2 plus 3x squared. Means that now you have this. Okay, So you have this, so you need to multiply with 1 minus x. Okay, so when you get all the same denominators, basically we can just cancel off all the denominators on the left and right side. Then you can just write down the numerators. So to get the unknowns a, b, c, just let the factor be 0. So first of all, I will let negative 2 over 3, I will let 2 plus 3x be 0. That means my x is going to be negative 2 over 3. So then the left hand side, you will get 8 plus 5 times negative 2 over 3 plus 12 times negative 2 over 3 squared. Then the right hand side, as long as you get 2, you see 2 plus 3x. That means this is going to be 0. Here is 0. Then you can find the c directly. Okay, then I will get c brackets 1 minus negative 2 over 3. Then now from here, you will get 10 equals to 5 over 3c. Hence, the c is going to be 6. Now, the next factor that I'm going to let it be 0 will be the next one, which is 1 plus x. Okay, I will let this be 0. So then, 1 minus x, not 1 plus x. Let 1 minus x be 0. Therefore, the x is going to be 1. So the left hand side, 8 plus 5 times 1 plus 12 times 1. Then it will be a brackets 2 plus 3 times 1. Okay, then the other two terms, two factors here will be 0. That means now you will be getting 25 equals to 25a. Then now the a is 1. So since we have found the c and a, to find the b, we don't have other factors. Therefore, we just let x be any other numbers. The easiest is just let x be 0. So when x equals to 0, left hand side is 8. Because 5 times 0 plus 12 times 0, it will be 0. Then now I will direct replace. So my a, 2 times 3 times 0 will be 2 squared. Plus the b, then 1 minus 0 is 1. 2 plus 3 times 0 is 2. Plus c brackets 1 minus 0 is 1. Okay, after that, you just replace the c and a. My a is 1, so this is 4. Plus 2b, my c is 6. Therefore, from here, you will be getting 2b is minus 2. Hence, your b is minus 1. So with these three values, just need to rewrite your partial fractions. Then that will be the solution for the part A. Okay, so that's all for this partial fractions. Next part, B. Hence means use the previous answer. Obtain the expansion of fx in ascending powers of x up to and including the term in x squared. So now I have to rewrite my fx. Just copy from the previous partial fractions, all these terms. So I will get 1 over 1 minus x minus 2 over 3 plus 2 plus 2 plus 3x. Plus 6 over 2 plus 3x squared. Okay, so from here, I will move up all the terms because I need to do binomial expansion. This is going to be 1 minus x to the power of negative 1, negative 2 plus 3x to the power of negative 1, plus 2 plus 3x to the power of negative 2. And then to use the binomial expansion, make sure it follows this. So a plus b to the power of n. Sorry, we are not using this now. We are using 1 plus x to the power of n because now your n is not positive integer. It is negative integers. So therefore, you must use this formula. It will be 1 plus nx plus n minus 1 over 2 factorial x squared and so on. Okay, but there is a rule for you to use this formula. The first one is first term must be 1, and then the second rule is must be plus. Alright, so now when you look at the first bracket, it is 1 minus. Therefore, I will rewrite this into 1 plus negative x. Negative. Excuse me. You are given 2 plus 3x to the power of negative 1, so I will factorize the 2. Because our purpose is to get 1. So here is going to be 1 plus 3 over 2x to the power of negative 1 plus factorize the 2, 1 plus 3 over 2x to the power of negative 2. Okay, and now just apply the formula. So this is going to be just up to x squared, means just expand until x squared. So it will be 1 plus n is minus 1, then x plus n is minus 1, n minus 1. So that means this is minus 2 over 2 factorial, then minus x squared, because our x now becomes minus x. Okay, so we have few more terms. And then the next one is going to be negative half. Okay, you bring in this negative to half and also to this bracket. Same as the next one. So 2 to the power of negative 1 is half. So I will get negative half. This negative, okay, the negative over here is because of the negative in this step. Okay, so then from here, you just do expansion. It will be 1 plus your n is minus 1 degree. I mean the degree is minus 1, so it will be n is minus 1, so 1 plus nx. So your x is 3 over 2 x plus minus 1 minus 2 over 2 factorial, then 3 over 2 x squared. This is the second expansion. And the third expansion, this is 2 to the power of negative 2. That means it's 1 over 4. So I will get plus 1 over 4. And now the degree is minus 2. Okay, here, negative 2 for these two terms. So then I will get 1 plus n is minus 2. The x is 3 over 2x. Then plus n is minus 2. N minus 1 becomes minus 3 over 2 factorial. 3 over 2 x squared. Alright. Then from here, just do expansion or simplify all these terms first. Right? Then you will be getting 1 plus x. The next one is going to be x squared. Then here minus half, rewrite. So inside the brackets, you will get 1 minus 3 over 2x plus 9 over 4x squared when you do expansion. Okay, let me write plus dot dot dot. because this is not the full expansion. And lastly, plus 1 over 4. Again, when you simplify the terms inside the square brackets, you will be getting, okay, let me check. Alright, I miss out the 6 over here. See, there's a 6. So I should have a 6 here. Okay, let me erase this first. Here should have a 6. Right. Let me rewrite. Okay, here should have a 6. Then here should have a 6. So the 6 over 4 is 3 over 2. Okay, this one no longer 1 over 4. Becomes 3 over 2. Okay, so then you will get 1. So then when you simplify, this is minus 3x then okay, then this one is going to be the 2 cancel, so 27 over 4 negative, so negative 27 over 4. Okay, it's positive because minus minus is a plus, then x squared. Then now when we do expansion or open all the brackets, it will be 1 plus x squared. Then now you do expansion again, multiply in, that will be negative half plus 3 over 4 x minus 9 over 8 x squared. Then again here when you do expansion, I will get plus 3 over 2 minus 9 over 2x, then plus 81 over 8 x squared. Okay, then at last, then now when you simplify, here 1 plus 3 over 2 is 2. 2 minus half. Okay, let me check. 1 minus half is half. Okay, half plus 3 over 2 is 2. Right? And then for the x, 1x, 3 over 4x, minus 9 over 2x. So you will get minus 11 over 4x. Then for the x squared, 1x squared minus 9 over 8x squared plus 81 over 8x squared. At last you will get positive 10x squared. So that's the binomial expansion for this question. Okay, next question, number 10. The diagram shows the curve 2 minus x times exponential negative half x and its minimum points m. Find the exact coordinates of m. So when you are given minimum points, means that the stationary point, and this is the stationary point, which means dy dx equals to 0. Okay, so now y equals to 2 minus x exponential negative half x. So obviously this is multiplication of two terms, and to differentiate this you need to apply the products rule. So this is uv prime plus vu prime. Okay, so now our u is 2 minus x. So u prime is minus 1. V is going to be exponential negative half x. Then the v prime, to differentiate exponential, you rewrite the whole exponential. function and then differentiate the power of e. So we differentiate negative half x is going to be negative half. So then my dy dx, it will be 2 minus x, which is our u, and then negative half e negative half x, this is my v prime, plus u prime v or v u prime. So I will get negative e negative half x. So then from here, I need to find the x coordinates first of the m. That means I need to solve the x here, right? So first of all, I will factorize the common term. Basically, the common term is negative exponential. Okay, and I can factorize a half because I don't want any fraction inside the bracket. So I factorize negative half e negative half x. So first term left 2 minus x. Second term, since I factorize a half, that means you will have plus 2. Okay, then now I further simplify. You will get 4 minus x inside the bracket. And now, at m, dy dx equals to 0. So 0 equals to negative half e positive half x multiplied with x 4 minus x. But we know that exponential cannot be 0. Okay, negative half x. So we know that negative half e negative half x cannot be 0 if you refer to the exponential graph. That means 4 minus x must be 0, and hence your x must be 4. So we found the x coordinate. Then now, just substitute the x into the y function. Then that will be the y coordinates of the m. So when x equals to 4, your y is 2 minus x e negative half x. That means this is going to be 2 minus 4 e negative half times 4, which is minus 2e negative 2. That means the m is with coordinates of 4, negative 2e negative 2. So that's the exact coordinates of the point m. Okay, now B, find the area of the shaded region bounded by the curve and the axis. Give your answer in terms of E. So let's check the graph first. So now I need to find what is this point. Okay, this point is when y equals to 0. So now y equals to 2 minus x exponential negative half x. When y equals to 0, okay, that means 2 minus x equals to 0 because the e negative half x cannot be 0. Okay, which means your x equals to 2. Therefore, I know that this is going to be 2. So now my region is from 0 to 2 and then this graph. So now I have to integrate from 0 to 2 the graph. So when we need to do this integration, since this is multiplication of two terms, that means this is going to be integration by parts, right? So now my u is 2 minus x. For your information, integration by parts is integrate u dv over dx, that is uv minus integrate v du over dx. If with limits, then just add on the limits for all the terms. So this is the by parts formula. Alright, that means now my u is 2 minus x, then my u prime is minus 1. So v prime is exponential function. My v is to integrate the exponential function. So when we integrate exponential function, you just rewrite the whole exponential function. Now you differentiate negative half x, it will be over half. But then when you divide by negative half, it's basically times negative 2. Okay, this is your v. Alright, so now by using the formula or just substitute into the formula, I'll get uv. Okay, this is my v, uv. So just multiply. It will be negative 2 minus x times exponential function. Consider the limits. Minus integrate v du. So when v du, minus minus is a plus. So I will just write positive. Okay, so now replace the x by 2 first. So when you replace by 2, 2 minus 2 is 0. So it means that first term is 0. Then I minus the lower limit. So when you replace the x by 0, okay, when you replace the x by 0 here, it's basically minus 2 times 2, which is 4. I mean minus 2 times 2 is minus 4. Okay, so I will get minus 4 e. Negative half times 0 is 0. Then now, this negative 2, I can take it out. So negative 2. Now, for this integration, it is this result, the v. Okay, so I will just copy minus 2e negative half x. Limits from 0 to 2. Then from here, you will get e0 is 1. Okay, here e0 is 1. Then I will get 4 for the first term. And then this minus 2, take it out and combine, then you get plus 4. And now, replace the x by 2. So e negative 1, then minus e0. So at last, you will get 4 plus 4e power negative 1. And again, e0 is 1. Okay, so you will be getting minus 4. So at last, the final answer is 4e to the power of negative 1. So that's the exact area of the shaded region. Okay, now let's move on to the next question. Two lines have equations. So these are the two equations. A, given that the two lines intersect. Find the value of A and the position vector of the points of intersection. So when they're intersecting means that you have to solve the simultaneous equations. So I will let R1 equals to 1i, 2j, 1k plus lambda of A2 negative 1. Okay, I express in this vector form. And then my R2 is going to be 2i, 1j, negative 1k plus mu of 2i minus 1j and positive 1k. So I will let R1 be R2 to get the intersection point. So now 1, so when I open the brackets, so 1 plus A lambda, then 2 plus 2 lambda, okay, here, then 1 minus 1 lambda equals to, open the brackets, 2 plus 2 mu, 1 minus mu, minus 1 plus mu. Okay, so solve these three equations. So now I will use second equation plus with third equation. So for the left hand side, 2 plus 1 is 3. 2 lambda minus 1 lambda is plus lambda. For the right hand side, you will get 0. Okay, that means now my lambda is minus 3. So because the question says they are intersecting, so it means that I just need to find two unknowns. Okay, so from the lambda and mu, then later I can just substitute into the first equation to get the A. So now, once I have solved this, I refer to second equation because I get this result from second and third equation. So now, from second equation, 2 plus 2 lambda is minus 3 equals to 1 minus mu. That means here you get 2 minus 6 equals to 1 minus mu. Therefore, your mu is minus 4. This is minus 4, here is 1. So 1 plus 4, which is 5. So I found the mu and lambda. Then to find the A, I will just substitute into the first equation. So 1 plus A lambda is minus 3 equals to 2 plus 2 mu. Mu is 5. Then from here, you will get 1 minus 3A equals to 12. Okay, then 3A is minus 11. Therefore, the A is going to be negative 11 over 3. Okay, so done for the first part, value of A. And now, for the intersection point. So intersection points, just find one of them, either the R1 or R2. So I will just refer to the R2 because it needs just the mu. Alright, so I will just write R2 equals to 2, 1 minus 1 plus, okay, refer to here, 2, 1 minus 1 plus mu. Our mu is 5. So 5 times 2 minus 1, 1. Then from here, I will get 2 plus 12. 5 times 2 is 12. Okay, or maybe I do it step by step. Then you will be getting 12 minus 4, 4. Okay, then now go back to question, position vector. So I will just write position vector of the intersection point equals to 12 minus 4, 4. Okay, so that's all for this part. Now, next part. B, given instead the acute angle between the directions of the two lines is inverse cos 1 over 6. Find the two possible values of A. Okay, so now let's say this is the first line, L1, L2. This is the B1 direction vector. This is the direction vector 2. And acute angle, let's say it is alpha, is given inverse cos 1 over 6, which means alpha, let alpha be the acute angle between two directions. Okay, between two directions of the lines. So alpha is inverse cos 1 over 6, which means cos alpha is 1 over 6. Okay, so now we use B1, the scalar products formula. B1 dot P2 is magnitude B1 magnitude B2 cos alpha. So the B1 is from the line 1. Line 1 is the R1, which means it is A2 minus 1. So just write as A2 minus 1. The B2 is from the R2. So your R2 is 2 minus 1, 1. So the B1 magnitude is going to be square root of square for each component. Square root, the modulus of B2 will be 2 squared, square root of 2 squared plus minus 1 squared plus 1 squared. Then cos alpha is 1 over 6. So for the left hand side, right, you just do expansion and plus all together. That is the scalar products or dots products. So I will get 2a minus 2 minus 1. Then the first square root, you just write a squared. 2 squared is 4. 4 plus 1 squared is 5. Then 2 squared plus 1 squared plus 1 squared, it will be square root 6. Then times 1 over 6. So now, to simplify this, we have a formula. Square root A times square root B is going to be square root of AB. Right, therefore, these two square root will be combined together. So I will write 2A minus 3 equals to square root of 6 bracket A squared plus 5. Then times another 1 over 6. So probably I will just times 6 to the whole equation. So I times 6 over here. Okay, so then I will get 12a minus 18 equals to square root of 6a squared plus 30. Now to get the a, square both sides. So when I square both sides, the first one we do expansion, it will be 144a squared minus 432a plus 324. Right hand side, just rewrite 6a squared plus 30 because the square and square root cancel off. Then now move all the terms to the left side. 144a squared minus 6a squared will be 138a squared. So negative 432a, 324 minus 30. This 30 you move to the left side. Okay, all the terms move to the left side. Then you will be getting plus 294. That equals to 0. So all these terms can be divided by 6. So when I divide by 6, you will be getting 23a squared minus 72a plus 49 equals to 0. And this quadratic equation can be factorized into 23a minus 49 multiplied with a minus 1 equals to 0. Hence, 23a minus 49 equals to 0, or a minus 1 equals to 0. Okay, which means you will get a equals to 49 over 23 or 1. Okay, so these are the two a values. Right, so we have come to the end of the video. Thank you for watching. If you enjoy watching my video, please subscribe to the channel and recommend it to your friends. And stay tuned for more upcoming videos. Thank you everyone. Bye.